Welcome to class, guys. It is me, Abu Michael, aka Abu Miki, your physics online tutor. In this class, I'll be looking at the topic projectiles. What exactly is projectiles? This refers to objects that are thrown obliquely into the air and are under the influence of gravity. Projectile motion is the motion of objects that form a parabolic or a trajectory path as they travel in the air. That is an example of projectile motion. Let me show you more examples of projectile motion. Applications of projectile motion. Projectiles have application in warfare. Now, talking about war, I'm going to let you see what war is like in those days. That is a war front. And what you're about to see is real war. Oh, you didn't see that, right? What I'm talking about, check the arrows. Arrows in projectile motion. Thank God we're in the 21st century and nobody's going to fire arrow through my lungs. Projectile can also be used for sports. Examples of projectile motion: a free kick by a football player, e.g. Neymar, Ronaldinho, Lionel Messi; a launch or released missile; the movement of the tennis ball on the board as it is being played. Projectiles can be discussed under two different categories: with angle of projection or without angle of projection. Whether it's with angle of projection or not, projectile motion has two components, which are horizontal component and vertical component. It is important to note, however, that these two motions are independent of each other. Projectile without angle of projection. It is important to note that for horizontal motion, the initial velocity of the object is always constant. So, the initial velocity is equal to the final velocity. Distance is an horizontal quantity and it is represented by S is equal to UT, or R is equal to UT. We might also write S is VT equal to VT. That is because initial velocity U is always equal to the final velocity. For vertical motion, however, velocity increases for a falling object. Hence, initial velocity U is not equal to final velocity V. U is always 0 meters per second and have final velocity that is dependent on the height from which the object is falling from. With the height is a small height, then V is going to have a small value. But if the height is a large height, then V obviously is going to have a larger value because velocity increases as an object falls downward. Height. Velocities are quantities that represent vertical motion. Only time is constant or the same for both horizontal motion and vertical motion. Now check out these three formulas. These are the formulas we use in addressing vertical motion. They are a formula that addresses a falling object since initial velocity is 0 in the original equations of motion when it's under the influence of gravity. Now, when this u is 0, then obviously the formula becomes like the one above. And when u squared is 0, then it becomes like the one above also. So all the formulas above were derived from these three original equations of motion. So when you have v equal to t, you got alright. Let's check example number 1. I trust at this time you must have been through with reading. When you want to solve questions like this, you will bring out the two components of motion, the horizontal motion and the vertical motion. This is the best way to going about solving questions like this. Remember, we said that distance is an horizontal component and height is a vertical component. Initial velocity is always constant for horizontal motion, but if it's a vertical motion, then the initial velocity will be 0. But we said that the time is always constant for both of them. So time is constant for horizontal motion and is constant for vertical motion, meaning the time for horizontal motion is also the time for vertical motion. That is why we have t in the horizontal section and t in the vertical section. Now, when you check out the parameters, because I trust you must have written them down or you are following me, you will have to solve for time first, and to do that, the vertical motion parameters will be the best way to go. So when we use that formula, h is equal to half gt squared, and we plug in values, then eventually we get the final answer for time. Example 1 continues. If we don't want to use the formula we just used in solving, we can combine them using this relationship. Anytime you are asked to find distance, you might try using this value if you've been given height and initial velocity. Do not forget that it might as well be written as s equal to 2 times square root of 2h divided by g. So if you have h using r, you may want to use s is equal to u square root 2h all over g. It is the same thing. Now if we plug in that relationship, we're going to get that, and we'll be getting the same answer. Now this is a question for you. I would like you to maybe write it out and try to solve it yourself. Or you can pause the video, try to solve it first before checking if your answer is correct. Alright. That's it. If you got 125 meters, then your answer is Correct. Now we shall be looking at projectile motions with angle of projection. Just like projectile motion without angle of projection, projectiles with angle of projection also have two motions. But in this case, we rather say two components. The horizontal component of motion and the vertical component of motion. The horizontal component is u subscript x, and the vertical component is actually v subscript y. If you don't want to use this subscript, you may just do it this way, write u subscript x for horizontal component or v subscript x. Component will use v subscript y. So the x that is written in this note should have been, this x should really have been y. It should really have been y. Okay, so the horizontal component is Vx is equal to u cos theta, and Vy is equal to u sine theta. So that's it. It is important to note here also that the horizontal component of projectile motion is constant, but the vertical motion varies because vertical motion is subjected or is influenced or is affected by gravity. Now, this is a very quick question for you because in Nigeria or in West African country, sometimes their questionnaire do ask, why is the horizontal component of motion constant? Well, the horizontal component of projectile motion is constant because it is not affected by gravity. But the vertical motion is not constant because it is affected by gravity. Having said that, this is an example of projectile motion with angle of projection. Please observe carefully. Now, that's it. I'll play it again so that you observe something. Please pay attention to the red arrow and the green arrow. You see the green arrow reducing as it's going upward, then it's increasing downward as it's coming down, while the red arrow is always constant. We'll talk about that in the next section. Now that's a video to depict what has been shown before. Okay, from the videos shown, it is clear that the vertical component of velocity is 0 at maximum height, while the vertical component of velocity decreases to 0 as it gets to maximum height and increases as it goes from maximum height downward. I will stop my class here and I will continue in the next section. So I will be releasing another video as a continuation of this class. Thank you very much.